Alright guys, we're going to be solving another question from the second chapter of the Meriam textbook, Engineering Mechanics. And in this one, we have the tension in the cable AB, which is 100 newtons. We need to determine the moment of that tension about point O. And we know that tension is applying at point O of the T-bar shape. And we also know that the dimension B is 600 millimeters. So if we look at this, it seems that point A and O are in the same line, but if we look at point A, we'll see that A is slightly to the left of point O. So if we draw a line in here, actually our A is a little bit to the left of point O. So let's call this angle right here theta, and at the end of this we will have the tension in here, which we can show it in here as our tension T. So we need to find the moment about point O. So for finding that, we know for finding the moment about point O, we can consider for our position vector any line that connects O to the line of action of T would be our position vector. But here, if we do this one as our R or our position vector, basically our T can be shown like this too, because this is the line of action of T. So if that's our T, we can resolve that force into two components. So this will be the X component of our T, and this will be the Y component. We can show it Tx and Ty. So the resultant of Tx and Ty would be our T, which is what we have in here. And also we have this angle here, theta. So we can see that Tx won't make any moment about point O, and we only have the moment of Ty. So for finding the moment in here, counterclockwise positive as always, all we need to do in here is just to find our Ty. And first of all, as we can see, the moment of Ty about point O is clockwise, so we have a negative sign Ty times the distance, which is our B, and we also know B is 600 millimeters. So we just need to find Ty, but for finding Ty, we need to figure out that angle theta, because our Ty would be T cosine of theta. This is what we're just talking about, the absolute value of the Ty. So that means that we have to figure out our Ty in here. Again, the figure is a little bit misleading because the point A and O are not at the same line. The point O is a little bit to the right, like regarding the X component. Our O is a little bit to the right of, so we have to watch that for finding the theta, because you might say that we can do, okay, tangent of theta would be pretty easy. We have the opposite, which is B over the adjacent. I'm going to explain how we can find that side, but the thing is that the numerator is not actually B, since the A is a little bit to the left compared to that. So let's get back, see how we can find that distance in here. So we are looking at this yellow right triangle. So this point is actually not O. We can call it maybe AB. Maybe we can call that one C. And if we want to find the tangent of theta, we basically have CB over AC. Okay, let's see how we can find BC first. So for finding BC, if we continue what we have in here, a perpendicular line to this, and we can call this one D, we can find DB pretty easy. So we have this green right triangle in here. Also, if we look at another triangle in here, this angle here would be also 30 degrees. So for finding CB, all we need to do in here is just to do DB. So let's say we want to find CB. Again, CB is the point in here. So for finding the CB, we can do DB minus this little part in here, which we can call this one EF. So we have DB minus EF, that's going to give us CB. And here, if we want to find the AC or the denominator, we have basically ED, which is this side, plus this little part in here, we can call that one plus AF. So if you want to find BD or DB in here, so for finding the DB in here, we basically have the distance from D to B, which we have B plus the base of the right triangle, which this time would be B cosine of 60. So that's dB. And for finding the EF, we basically have the base of the other right triangle. I'm going to show it in red. And we know the hypotenuse is B over 2. So we have 1/2 of B times cosine of 30 degrees. And for the bottom, it's ED plus AF. ED would be, if we look at the green triangle, we have B sine of 60. So we are looking for this side. And for the red part, we need this side, which is AF. So our AF would be plus 1/2 of B. Again, this time we'll have sine of 30 degrees. So now that we have the tangent of theta, our theta would be tangent inverse of this value in here. We can factor 1b in here on the numerator. So if we factor b, we have 1 plus cosine of 60 degrees minus 1/2 of cosine of 30 degrees. And we can also do the same in the denominator. So 1 sine of 60 times 1/2 of sine of 30. The b will be cancelled out, and all we need to do is just to figure out this value to find our theta. So tangent inverse of 1 plus cosine of 60 minus 0.5 cosine of 30 divided by sine of 60 plus 1/2 of sine of 30. So now our angle here would be 43 degrees, 0.70. So the angle will be 43.71 degrees. And that was the hardest part of this question. The rest is pretty easy. We have the force T, which we know is 100 times cosine of 43.71 degrees times B, which is 600 millimeter. We're going to divide it by 1,000 to get it in meters. So our moment would be negative 100 cosine of 43.71 times 0.6. And this is going to be the final answer, 43.37 Newton meter. And the negative sign shows that the moment is clockwise. I hope everything was clear. Yeah, let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.